Hello everyone, I am Shubham Mudgal. I'm a student of CU Boulder and this is my presentation for CSCI 5448 on object-oriented programming differences between C++ and Java. So let's start with the definition of object-oriented programming. The most basic and simplest definition of object-oriented programming is that it's a programming paradigm based on the concept of objects, which are data structures that contain data in the form of fields, often known as attributes, and code in the form of procedures, often known as methods. Now, there are four basic concepts of object-oriented programming. These are polymorphism, encapsulation, abstraction, and data hiding. I'm not going in details of any of these because that's not our topic of discussion today. So let's move forward with the differences. So there are So how is object-oriented programming in Java different from object-oriented programming in C++? In Java, everything must be in a class. Now, there are no global functions or global data. If you want the equivalent of globals, make static methods and static data within a class. There are no structs or enumerations or unions, only classes in Java, whereas all these are present in C++ language. All standalone C++ programs require a function named main and can have numerous other functions, including both standalone functions and functions that are a member of a class. However, there are no standalone functions in Java, instead only functions that are members of a class, usually called methods. So C++ is considered to be a hybrid object-oriented language and Java as a purely object-oriented language because in Java we have everything in a class and everything has to be represented in form of objects. Class definitions, let's go on syntax, are roughly the same form in Java as in C++, but there's no closing semicolon while defining a class in Java. There are no class declarations of the form class, Java class, only class definitions. So, as in C++, we could give class declarations and define the class afterwards. So, that's not the case in Java. There's no scope resolution operator, the double colon in Java. Java uses the dot for everything, but can get away with it since you can define elements within a class. Even the methods definitions must always occur within a class, so there is no need for scope resolution there either. One place where you'll notice the difference is the calling of static methods. You say class name dot method name. In addition, package names also are established using a dot, and to perform a kind of C++ include hash include, you use the import keyword. Java uses singly rooted hierarchy. So all objects are ultimately inherited from a root class called object. In C++, you can start a new inheritance tree anywhere. So you end up with a forest of trees. In Java, you get a single ultimate hierarchy. This can seem restrictive, but it gives a great deal of power since um, you know that every object is guaranteed to have at least the object interface. C++ appears to be the only object-oriented language that does not impose a singly rooted hierarchy. So C++ is different from all in this case. Inheritance in Java has same effect as C++. but the syntax is different. Java uses extends keywords to indicate inheritance from a base class and super keyword to specify methods to be called in the base class that have the same name as the method you are in. So the base class scoping in C++ allows you to access methods that are deeper in hierarchy. The base class constructor is also called using the super keyword. As mentioned before, all classes are ultimately automatically inherited from object. There is no explicit constructor initializer list like in C++, but the compiler forces you to perform all base class initialization at the beginning of the constructor body, and it won't let you perform these later in the body. Inheritance in Java doesn't change the protection level of the members in the base class. Now, you cannot specify public, private, or protected inheritance in Java as you can in C++. Also, overridden methods in a derived class cannot reduce the access of the method in the base class. For example, if a method is public in the base class and you override it, your overridden method must also be public. So otherwise it won't allow you to override it. Java doesn't provide multiple inheritance, so that's not new for us, at least not in the same sense as C++ does. Like protected, multiple inheritance seems like a good idea, but you need it only when you are face to face with certain design problem. So it depends on what kind of problem you're in and what's the solution that you're seeking. Since Java uses singly rooted hierarchy, you'll probably run into fewer situations in which multiple inheritance is necessary. Java provides the interface keywords instead, which creates an equivalent of abstract class filled with abstract methods but with no data members. This makes a clear distinction between something designed to be just an interface and an extension of existing functionality via extends keyword. It's worth noting that abstract keyword produces a similar effect in that you cannot create an object of that class. An abstract class may contain abstract methods, although it isn't required to contain any, but it is also able to contain implementations, so it is restricted to single inheritance. So here we have the example of washable interface and an object, and the class cup is inheriting from object and it's implementing the washable interface. So there is no virtual keyword in Java because all non-static methods always use dynamic binding. In Java, the programmer doesn't have to decide whether to use dynamic binding. The reason virtual keyword exists in C++ is so you can leave it off for a slight increase in efficiency when you're tuning for performance. Or put it another way, if you don't use it, you don't pay for it. Which often results in confusion and unpleasant surprises. The final keyword provides some latitude for efficiency tuning. It tells the compiler that this method cannot be overridden and thus that it may be statically bound. Exception specifications in Java are vastly superior to those in C++. Now, instead of C++ approach of calling a function at runtime, when the wrong exception is thrown. Java exception specifications are checked and enforced at compile time. In addition, overridden methods must conform to the exception specification of the base class version of that method. They can throw the specified exceptions or exceptions derived from those. This provides much more robust exception handling code. Java has method overloading, but no operator overloading. The string class, now here's an exception. I mean, what an irony here. The string class does use the plus and plus equal to operators to concatenate strings and string expressions, use automatic type conversion, but that's a special built-in case. Java contains libraries for solving specific tasks. C++ relies on non-standard third-party libraries. These tasks include networking, database connection via JDBC, multi-threading, distributed objects, compression, commerce. Now, the availability and standard nature of these libraries allow for more rapid application development. Although they look similar, but arrays have a very different structure and behavior in Java than they do in C++. There's a read-only length member that tells you how big the array is, and the runtime checking throws an exception if you go out of bounds. All arrays are created on a heap, and you can assign one array to another. The array handle is simply copied. In this case, the array identifier is a first-class object with all of the methods commonly available to all other objects. Also, no forward declarations are necessary in Java, unlike in C++. What that means is if you want to use a class or a method before it is defined, you simply use it. Now, this is not the case in C++. You have to have a declaration first and then use it, and then you may define it afterwards. But so the compiler ensures that the appropriate definition exists somewhere in the program, somewhere. Thus, you don't have to have any of the forward referencing issues that you do in C++. Excuse me. Java uses packages in place of namespaces. Okay. The name issue is taken care of by putting everything into a class and by using a facility called packages that performs the equivalent namespace breakup for class names. Packages also collect library components under a single library name. You simply import a package and the compiler takes care of the rest. Object handles defined as class members are automatically initialized to null. Now let's see what this is. Initialization of primitive class data members is guaranteed in Java. If you don't explicitly initialize them, they get a default value of is 0 or equivalent. You can initialize them explicitly either when you define them in a class or in a constructor. The syntax makes more sense than that for C++ and is consistent for static and non-static members alike. You don't need to externally define storage for static members like you do in C++. So there are no Java pointers in the sense of C and C++. When you create an object with new keyword, you get back a reference. For example, it's given string s equals to new string howdy. However, unlike C++ references that must be initialized when created and cannot be rebound to different location, Java references don't have to be bound at the point of creation. They can also be rebound at will, which eliminates part of the need for pointers. The other reason for pointers in C and C++ is to be able to point at any place in memory whatsoever, which makes them unsafe, which is why Java doesn't support them. Pointers are often seen as an efficient way to move through an array of primitive variables. Java arrays allow you to do that in a safer fashion. The ultimate solution for pointer problems is native methods. Passing pointers to methods isn't a problem since there are no global functions, only classes, and you can pass references to the objects. And there are no destructors in Java. So here comes the topic of garbage collection in Java. There is no scope of a variable per se to indicate when the object's lifetime is ended. The lifetime of an object is determined instead by garbage collector. There is a finalize method that's a member of each class, something like a C++ destructor, but finalize is called by the garbage collector and is supposed to be responsible for releasing resources such as open files, sockets, ports, URLs, etc. If you need something done at a specific point, you must create a special method and call it, not rely upon finalize. Put another way, all objects in C++ will be, or rather should be, destroyed, but not all objects in Java are garbage collected. Because Java doesn't support destructors, you must be careful to create a cleanup method if it's necessary and to explicitly call all the cleanup methods for the base class and member objects in your class. Garbage collection means memory leaks as are much harder to cause in Java, but not impossible. If you make native method calls that allocate storage, these are typically not tracked by the garbage collector. However, many memory leaks and resource leaks can be tracked to a badly written finalize method or to not releasing a resource at the end of the block where it is allocated. The garbage collector is a huge improvement over C++ and makes a lot of programming problems simply vanish. It might make Java unsuitable for solving a small subset of problems that cannot tolerate a garbage collector. But the advantage of garbage collector seems to be greatly outweigh this potential drawback of it. There is no goto in Java. So goto is like a reference to some other in some other part of the program. The one unconditional jump mechanism is the break label or continue label, which is used to jump out of the middle of multiply nested loops in Java. Java has built-in multi-threading support. There's a thread class called that you inherit to create a new thread. You override the old one run method, Mutual exclusion occurs at the end of objects using the synchronized keyword as the type qualifier for methods. Only one thread may use synchronized method of a particular object at any one time. Put another way, when a synchronized method is entered, it first locks the object against any other synchronized method using that object and unlocks the object only upon exiting the method. There are no explicit locks, they happen automatically. You are still responsible for implementing more sophisticated synchronization between threads by creating your own monitor class. Recursive synchronized methods work correctly, and time slicing is not guaranteed between equal priority methods. So here comes to the conclusion of my presentation. C++ is a powerful and high performance language, and many of the industry software is still written in C++. Most of, if not most of them, many of them who require system performance, since C++ is faster, much faster than Java, but Java is simpler to use and it reduces a lot of, it vanishes like a lot of problems based of programming. But C++ is still widely used in the industry for its performance quality. Now, generally, Java is more robust than C++ because it handles references are automatically initialized to null, as we have already discussed. Handles are always checked and exceptions are thrown for failures. So suppose we are in a if-else loop in Java, and suppose there are no exit criteria for if one of the situations are not mentioned explicitly, then the Java will throw you an error and it won't let you compile the code. So exception handling is pretty good here. All array accesses are checked for bound violations, which is not the case in C++, where you can have unbound arrays. And automatic garbage collection prevents memory leaks, which is also a huge deal. And clean, relatively foolproof exception handling. Also a simple language support for multi-threading. So these are the advantages of Java over C++. Okay, here are the references for my presentation, and I hope you learned something out of it, and thank you for being there with me.